So let's walk through an example. According to the Census Bureau, 8.8% of the U.S. population had no health insurance coverage in 2017. Suppose that in a recent random sample of 1,200 Americans, 130 had no health insurance. Use a 0.02 significance level to test the claim that the current percentage of Americans who have no health insurance coverage is greater than 8.8%. And again here, I'm going to use the p-value method. Now the first step is always to state our null and alternative hypothesis, which is something that we've practiced a little bit in the past, but here I'm going to look at the values that they're giving us here. So if I read the first sentence, it says, according to the Census Bureau, 8.8% of the U.S. population had no health insurance coverage in 2017. So this will be the claimed value of P that we're going to use in our null hypothesis. And the alternative hypothesis is testing the claim. So here, if I read the last sentence, test the claim that the current percentage of Americans who have no health insurance coverage is greater than 8.8%. So we're going to test the claim that P is actually greater than that. And that's sort of the original claim that we're going to try and support here with some evidence. And before I compute my test statistic, let's gather some sample data. Because in the problem, they also give us some numbers here, right? 1,200 Americans, 130 had no health insurance, right? That's coming from a sample that we conducted. So to get our sample data, we know that there was a sample size of 1,200. And we had 130 that had no health insurance. From that, we can get the p-value, or I'm sorry, the test sample proportion, p hat, which is our point estimate. So we'll compute 130 over 1,200. And let's see, if I calculate that, I get something around 0.108. Now remember, that's going to be part of our test statistic. So to compute the test statistic, we'll take our point estimate minus the value of P that we're claiming in our null hypothesis, and divided by the standard deviation, PQ over N square root. So 0.108 was our point estimate minus 0.088 was our claimed proportion. And then the square root of, now we're using PQ, so P would be the value that we're claiming here. Q would be, here for Q, let's remember that that's going to be 1 minus P hat. Not P hat, just 1 minus P. So it'll be 1 minus 0.088. And that gives me 0.912. And divided by our sample size, which was 1,200. Okay, so now when I punch this all into my calculator, I get a p-value of about 2.446. Okay. Remember, what is this telling me? This is telling me how many standard deviations away from the mean, or in this case, away from the population proportion, this sample data is, how many standard deviations. So it tells us in a way how unusual that sample data is relative to the claim, the population parameter that we're claiming. So here we'll now compute the p-value. To put it into a picture here, we calculated the test statistics, which remember was about 2.446. The form of our alternative hypothesis involved the greater than symbol, so here of course we're going to use a right tail. So what we want to find now is the p-value, which is the area of that region. So to calculate the p-value, well, we'll use the standard normal distribution and figure out what's the probability that we get a z that's greater than that, which we know how to do. This is a normal distribution, and we're going to stick with the standard normal distribution, which has a mean of 0 and a standard deviation of 1. So we can use normal CDF on our calculator. Here we've got the lower value of 2.446. You have the upper value of 1e99. Since we're looking at the right tail, it goes to the right forever. Standard deviation of 0 mean of 0, standard deviation of 1. So that's using the standard normal distribution. So punching all that into my calculator. I get a p-value of around 0.0072. Okay, and what I can clearly see is that this p-value is very small, and in particular it's smaller than the significance level that we wanted, which was 0.02. So if you remember, our significance level was 0.02, so we wanted to use that as a judge of whether or not we should reject or fail to reject. Now in this case, the p-value that we got was definitely less than alpha, right? 0.0072, which is definitely less than 0.02. So what does that mean? We're going to reject the null hypothesis. Okay, so that's the decision we're making based on where the p-value lands relative to our significance level. So now what we can do is try and interpret this with the original claim that we were making. Remember that we were originally claiming that the current percentage of Americans who have no health insurance coverage is greater than 8.8%. So since we're rejecting our null hypothesis, what does that tell us? And in fact here, well, let's think about the two cases here when we were making a type 1 or making a type 2 error. So remember, a type 1 error is the error of rejecting the null hypothesis when it's true. So in this case, that would mean that we reject the claim that we reject the claim that 8.8% of the population has no health insurance. So in other words, we support the alternative that p is greater than 0.088, when in fact that's false. Versus the type 2 error would be to failing to reject H0 when H0 is actually false. So in this case, we would not necessarily support H1, or not necessarily support H0, but we would fail to reject it. So we would fail to reject claim that P is equal to 0.088 when in fact P is greater than 0.088.